In this video, we'll look at rational exponents. And when we say rational exponents, we just mean exponents that are fractional values. And we'll start with some examples that kind of lead us to the rules. So we'll start with some rules that we're already familiar with. And we'll start with this simple example here. So simplify and evaluate. We have 25 to the 1/2 times 25 to the 1/2. Well, when we multiply two powers with the same base, the rule is that we keep the base and we add the two exponents. So in this case, we'll have 25 to the 1/2 plus 1/2. And we can go ahead and add those. 1/2 plus 1/2 is just 1. So we get 25 to the 1. And that in itself may not be all that interesting, but what it is interesting is that we took a number here, whatever this number happens to be, and we multiplied it by itself. And when we did that, we got 25 to the 1, or just 25. So we took a number, multiplied it by itself, and we got 25. That means that this number here must have been equal to the square root of 25. And if you think about that, the square root of 25 is 5. 5 times 5 would give us 25. So 25 to the 1/2 had to equal the square root of the square root of 25, which just happens to equal 5. So really what this problem was, is it said, we'll just kind of jump right back to the start of the problem. Another way to look at the problem, it just said the square root of 25 times the square root of 25. And you could break that down a little bit if you wanted to. Square root of 25 is 5 multiplied by 5, or when we take the square root of a number and multiply it by itself, we just get that number back. And so the square root of 25 times the square root of 25 is just equal to 25. But the important part right here is this part right here, I think. And the reason why that's important is it gives us a connection between fractional exponents or rational exponents and roots or radicals. So we've already kind of determined that the square root of 25 here would equal 5. And the reason why that's kind of important, we'll see in a minute, is that this value in the exponent will give us some kind of key information. The denominator in that exponent will help us out, and we'll see that in the next example. So let's take this one over here. A little bit different, but also kind of similar. We'll attack it the same way. We've got 8 to the 1/3 times 8 to the 1/3 times 8 to the 1/3. According to the rules for multiplying exponents, if we're multiplying powers with the same base, we keep that base and we add the exponent. So we'll get 1/3. So that's a bad looking 3. Try to fix it up here. That's not much better. There we go. So now we have these three fractions that we need to add together. They already have a common denominator. 1/3 plus 1/3 plus 1/3 just gives us 1 whole. So this is equal to 8 to the 1. So what that means is that we took a number, again, same sort of idea as last time. We take a number and multiplied it by itself 3 times. Give me a second here. Let's see if we can, there we go. We took a number right here, multiplied it by itself 3 times, and we got 8. So we took this number, which was 8 to the 1/3, multiplied it 3 times, and we got an answer of 8. And the interesting thing there is that we call that the cube root. When we take a number and multiply it by itself 3 times and get that number, that's called the cube root. So what this means is that 8 to the 1/3 is equal to the cube root of 8. And again, this cube root, we'll just write that in here just so you can kind of see that. That's the cube root. So the cube root of 8 is a number that multiplied by itself 3 times will give us 8. And there's a button on your calculator that will do this. Some things you might be able to pick out. This one, you might think, oh, I can do this one. 2 multiplied by itself 3 times would give me 8. So the cube root of 8 is just equal to 2. And again, maybe I'll just write this down here as well. So this cube root part here just means a number multiplied by itself. Should probably type this, it'll be easier to read, but multiplied by itself 3 times to get 8. And we see that 2 fits the bill there. 2 times 2 is 4, times 2 would give us 8. So the cube root of 8 is 2. That's this part right here. And the new way of expressing that, probably new for you, is this notation here. This 8 to the 1/3 is the same as the cube root. Now, I mentioned a little while ago that this exponent, the denominator in the exponent here, the 2, will play an important role. And maybe you can kind of see that a little better here. We had a denominator of 3, and that denominator told us which root it was that we were looking for. So let's maybe sort of summarize some of what we just did. We'll take that to the next slide, and we can do that over there. So I'm going to start with this right here. We'll start with some terminology. And we'll just kind of label a few things here. We'll start inside. So this number under the root sign is called the radicand. The radicand. And this number out front, now notice where this number is. One of the things that you'll see when you do some work with radicals, and we do call this whole thing a radical, sometimes you'll see a number out front here. Notice this 3 here is kind of tucked away inside the radical symbol. And that has a very different meaning than a 3 out front. So I just wanted to point that out because that is an important distinction. So this 3 here is often what we call the index. Let's try this. So we call that the index. And that just tells us which root, index has an E in it, which root we're looking for. So this tells us, in this case, we're looking for the 3rd root. What number multiplied by itself 3 times would give us 8? So the idea here was that the denominator in our exponent ended up being this index. I don't know if you noticed that back here. So our denominator here ended up being the index. And you might say, well, how come the 2 didn't show up here? And generally speaking, I mean, we could write a 2 in there, but generally speaking, the square root sign just written like this means a number multiplied by itself twice. So we would tend to leave out the 2, but if it's a 3rd root or a 4th root or a 5th root, we put that number in. So let's work through an example here where we're going to write this cube root of 8 squared using exponents. And again, notice that 3 is tucked up inside, right inside the radical sign there. It's not a coefficient out front, it's kind of tucked in there. So we've already determined, I should mention there are 2 ways to do this. The first one is to square the number 8 and then take the cube root. And the second one is to take the cube root of 8 and then square it. So we'll do that, but I want to show you first how we can write this using an exponent. So if we're going to write this with an exponent as an exponent, we know that we have the 8 squared, and we also know that 3, that index, should be the denominator that goes with the exponent. Let me fix that 3 up because that doesn't look very good. It's a little bit better. So there we are as an exponent. So noticing that that index ends up in the denominator in our exponent, and now we can multiply these 2 exponents together. We've got exponents to exponents. We can multiply those together, and we would get 8 to the 2/3. So in the previous examples, we always had a 1 in the numerator. This is how you can get a number other than 1 in the numerator. So the 3 in this case tells us which root we're looking at. I'll see if I can write that over here. And the 2 tells us which exponent we're looking for. Like your traditional exponent. I know that 2/3 is an exponent, but if this two would indicate that we're squaring this. And so that's why here we say that we can either square the 8 and then take the cube root. So that would look like this. Let's see, so 8, let me just change colors here. So 8 to the 2/3 we could write as 8 squared and then take the cube root. Well, 8 squared is 64, and then we could take the cube root of that. So the cube root of 64 is a number multiplied by itself 3 times. That'll give us 64, and that number should be 4. So that was the first way that we could do it, or we could do it the other way where we take the cube root first. The nice thing about doing it this second way is that generally the numbers are a little bit smaller, so you can probably do the calculations. Sometimes you'll be able to do the calculations in your head. So we could take the cube root of 8 first, and then square that answer. So the cube root of 8 just means what number multiplied by itself 3 times gives us 8. Use your calculator if you need to. This is going to be 2. 2 squared would give us 4. All right, let's move on. Oh yeah, this one's already done for us. Let's backtrack here a little bit. Let's do converting between these different forms, just so you can kind of get used to it. We'll keep that there as our example. All right, so here's the 5th root of 32 squared, and what we want to do is convert between exponential and radical form. So this one's in radical form, so let's go from radical form to exponential form. This index here of 5 indicates that the denominator on our exponent is going to be a 5. So this is going to equal 32 squared to the 1/5. Some of you might be able to say, oh, well, that just means that we're going to have a 5 in our denominator. So this becomes 32 to the 2/5. And if you can go right from here to here, that's fine too. All right, and let's go backwards. Let's go the other way. Just going to slide this over a little bit so we've got a little bit more room. Whoops, not that part. A little bit more room. This is 128. Just rewrite it to the 2/7. So it's in exponential, and we're going to turn this into radical form. And there are 2 ways that we can do this one. So we can say, well, this is just the 7, indicates that we're looking at the 7th root of 128 squared. Or we could say that 128 to the 2/7 is the same thing as the 7th root of 128, and then we square that result. And again, the nice thing here is if you do it this way, the numbers might be a little bit smaller. So the 7th root of 128, you can do that on your calculator, and you should get 2, and we get a squared out here. So we get an answer 4, which means that again, 128 squared is a very large number. I don't even think I wrote it down here. Let's see if I can find a calculator. So the 128 squared works out to 16,384. I said very big. It's not that big, I guess. Sorry, that should be a 384. And we're looking for the 7th root of that. I ran out of space, but so the 7th root of that, there should be a button on your calculator that will do an nth root or an x root. So let's just do the 7th root of 16,384, and we should get that same answer as we do of 4. Oh, there's that same slide, all ready to go. So that's an introduction to rational exponents and what their connection to radical form and how we can use them.